Assalamualaikum dear students, and our today's topic is the IV characteristics of ohmic and non-ohmic conductors. So basically the conductors for which the current versus potential difference graph gives a straight line are called ohmic conductors. Otherwise, if they do not show a straight line, then they may be termed as non-ohmic conductors. Alright, so basically the conductors which show a straight line when a graph is actually sketched out between the potential difference and the current, then these type of metals are called the ohmic conductors. And the conductors which do not show these kind of straight lines in a graph are called non-ohmic conductors, because they do not obey the Ohm's law. They do not obey the condition for the Ohm's law. Okay, so as the condition says, if the potential difference increases, then the current must also increase, and if the potential difference decreases, then the current must also decrease by a factor 1 by r. This factor gives out a straight line for the ohmic conductors. Okay, so this factor stays constant. This straight line shows that this factor stays constant for ohmic conductors, and these two graphs show that this factor does not stay constant for the non-ohmic conductors. Okay, so for the graphs for which 1 by r is constant are called ohmic conductors, and the graphs for which 1 by r is not constant is called the non-ohmic conductors, right? So there are basically three basic types of three basic categories for the ohmic and non-ohmic conductors. So first one हम स्टडी करेंगे are the metallic conductors. Basically बहुत छोटा सा ये आज का टॉपिक है, ज़्यादा लेंथी नहीं है, बट थोड़ा सा conceptual है. Metallic conductors gives us the straight slope. If they give us the straight slope, it means that they obey the Ohm's law. What does it mean? It means that if we just take del V along x-axis and I along y-axis, then if we just take del V divided by I, then what would happen? We will get a straight line joining all the points for all the readings that we take. It will give us this straight line. Okay, so basically metallic conductors, many metallic conductors and some alloys as well show this kind of behavior, and these type of conductors are called the ohmic conductors. Here resistance stays constant for any amount of potential difference or current applied to that conductor. The second type is the filament bulb. आपने अक्सर देखा होगा that एक tungsten bulb में filament होता है. That filament, that tungsten filament does not obey Ohm's law. How? It gives exponentially increasing curve. What is an exponential curve? This type of curve or this type of curve. Okay, इस तरह की जो भी ग्राफ में कर्व्स होती हैं, these are called exponential curve. Okay, so फिलामेंट के केस में हमें एक्सपोनेंशियल कर्व मिलती है जब भी हम कोई एक्सपेरिमेंट परफॉर्म करते हैं to measure its resistance value across the potential difference applied or the current applied. Okay, whenever we take such kind of experiments, then we see that this kind of graph is usually observed during the calculations. So for filament, it gives us the exponentially increasing graph, because at start, if we just increase the potential by a little bit, a huge current would be produced. But after the passage of some time, when we even increase the potential by a larger amount, the current won't really increase. Because ये इसलिए होता है because at higher potential differences, उस मेटल का टेम्परेचर भी हाई होगा. टेम्परेचर हाई होगा, देन उस जो हम करंट प्रोवाइड करेंगे, पोटेंशियल डिफरेंस प्रोवाइड करेंगे, उसकी वजह से जो करंट प्रोड्यूस होगा, उस करंट की, उन इलेक्ट्रॉन्स की, उन चार्जेस की उस मेटल के एटम्स के साथ बहुत ज़्यादा कोलिजन्स होंगी, कोलिजन ज़्यादा होंगी एट दिस पॉइंट, देन द रेजिस्टेंस विल बी इंक्रीज. जब रेजिस्टेंस इंक्रीज होगी देन करंट विल नॉट इंक्रीज. यहाँ पर पहुँचते पहुँचते टेम्परेचर इंक्रीज होता है एंड देयर फॉर द मोशन ऑफ इलेक्ट्रॉन विल ऑल्सो इंक्रीज एंड दस द current will decrease due to the decrease in due to the increase in resistance. Okay, so initially current increases with even very shorter amounts of potential difference, but after some time current will not increase much. This is due to the collision of atoms with the electrons due to increasing temperature, right? The third term is the thermistor. It gives exponentially decreasing curve. Okay, हमने पहले exponentially increasing curve पढ़ा. Now we are going to talk about exponentially decreasing curve. It says that at first when we even apply large amount of potential difference, a very small amount of current will be produced. But after some time, when we even just provide even a little potential difference, a huge change in current would be observed. You can see ये line कितनी छोटी है and ये line कितनी बड़ी है. Okay, so in this case even a shorter increase in potential difference will produce a larger amount of current over here. Okay, so this type of graph is called exponentially decreasing curve or exponentially decreasing graph. Here I increases much slowly at first, but after some time it starts to increase rapidly and thus resistance decreases sharply. Of course, जैसे ही I increase होगा then resistance decrease होगा. जितना ज़्यादा current increase होगा resistance उतना कम होगा, because it does not give us this straight line. It does not give us the correct ratio between V and I as the Ohm's law would have suggested. Okay, so in this case there won't be a straight line, there we will get a exponentially decreasing curve, and that is why the thermistor is a device basically which shows this kind of graph. The thermistor and the filament bulbs are non-ohmic conductors, are an example of non-ohmic conductors, and the metallic conductors in most of the cases, most of the metals and some of the alloys show a straight line between del V and I, and thus they can be termed as the ohmic conductors, right? Thank you so much everyone.